So basically, Amithi, so as you can see this thing, if I'm sitting right now, you are sitting in Dubai as well. So you're sitting firmly on the ground, on the sofa, on the bed, whatever you have right now, right? So basically that is also because of the gravitational force, right? You are attracted towards the earth, right? So basically in this chapter, we are going to study about the gravitational force. So this gravitation is a basically quantity that will produce a kind of force. That's why we are basically on the earth. Like everything is basically in organized manner. Everything is basically stable in its own, you can say, state, right? So, okay, could you please tell me who discovered the gravitation? Gravity or
Isaac
gravitation?
Newton.
Isaac Newton. Yeah, that's right. The apple is accident, right? That's great, Chana. So now let's discuss about this. In simple words, the earth, just a second, Aditi, actually my hands are slipping, just a minute. The earth attracts. So basically, we live on Earth, so that's why we will be talking about the Earth gravitational force, right? In generally, if I'm saying gravitation, that means we are talking about the Earth gravitational force, right? So Earth attracts all the objects towards its center.
Wait, so isn't gravitation like
Hmm.
universal and gravity based on Earth?
Oh, so gravitation is universal. Gravitation in the space is universal. If you are talking, but right now we are talking about just a general case of the Earth. The gravitation
Okay.
is all over the universe. But right
Mm.
now we are doing the, because the gravitation is not that much simple. It's very complex, right? So that's why in the general way we are talking about the Earth gravitation only, so
Mm.
that we can easily understand in the as per the you can say standard of ninth class. Okay?
Yeah.
Yeah, that's great. Towards its center. Okay, that's great. Okay, so Earth basically, so gravity, this attraction is basically towards the center. That's why we are basically, if we throw something in the upwards direction, everything will come towards the center of the Earth, right?
Mm.
So because Earth is a sphere, it's just like this thing. So if suppose this is there and you are sitting right here, just you are sitting right here, okay? So and if you throw something in the upwards, so after some time, it will basically come towards, and it is nothing but center. So it is coming towards the center of the earth. Yes or no, Miti?
Yeah.
Yeah. So that's why it says the earth attracts all the bodies, all the objects towards its center. Yeah,
Mm.
that's great. Chicken. Next would be the force with which earth pulls the objects towards the center or towards it is called gravitational force of earth. So the gravitational force of Earth means that the force with which the Earth attracts all the body towards it. Am I clear?
Yeah.
That's great. Okay, Amity. So basically, this is the general definition of the gravitational force of Earth. Right now, could you please tell me some applications of the gravitational force? in like whatever you experience in your day-to-day life?
Uh, Example could be us walking. We don't float around because of
Hmm.
gravity.
Yeah, that's very good example. And
And
yes, tell me.
as you said, throwing objects, it'll always land down.
Yeah, that's also correct. Another example could be rain falling on the earth. Basically, clouds are above the sky, and basically, there might be a possibility that the water can go in the upwards direction as well. But due to gravity, all the water comes down on the earth, all the water pours on the earth, right? And there could be the flow of water in the rivers, because there might be a possibility that water that is basically flowing in the river could go in the upward direction. But due to gravity, water basically is attracted towards the surface, so that's why it will flow with the surface itself. Okay, so
Yeah.
in the basic example, we are sitting firmly on the ground, so that is also due to the gravitational force of earth. Amithi, am I clear? That's great. Okay, so the gravitational, so that's why gravity is very very important in our day-to-day life.
Mm.
So how much they have covered in the school so far, Amithi?
Uh, we have just like started with the theory part.
Okay, so it means that they have just given the introduction of the gravitational force. Okay, that's great. Okay, that's great. Okay. The gravitational force of Earth is responsible. So these are some day-to-day life example. Responsible. So did you get the marks, Amiti, for the
Yeah.
pre-midterms? Sure, that's great. So what was the score for physics specifically?
For physics, it was out of 27. I got 23.5.
That's a very good number. Very good. It means that you have like your all the concepts are clear so far. Okay,
Mm.
that's great. So where did you lose the marks? Like for like 3.5 marks in the calculation or in the
Asked, as in, it was about force.
hmm.
They asked for friction. I did
Okay.
not know how to calculate for the friction.
So do you have friction in your ninth standard?
No, but the question included friction as well.
Okay, okay. I mean, you can do one thing. Like, did you get the checked answer sheet from your school and the question paper? Like, obviously, you will have the question paper as well.
Yeah.
Okay, so do one thing, Amiti. After this class, you can send the check. Like, did you get the checked answer sheet? Like PDF of the checked answer sheet, or do you have checked answer sheet right now with you?
No.
Okay, do one thing. If it's possible, to basically make a PDF of your checked answer sheet. Okay, please share that on the official number from which you have received the link, and please share your question paper as well, so that we can discuss those flaws like which you have made in the exam, so that you can basically avoid them in the coming portion. Okay,
Mm.
yeah, that's great. Atmosphere above the earth. Okay, so gravitation. So another example, you can say that gravitational force is responsible to keep us firmly on the ground. Okay, next would be, so what was your overall score in the science?
I did not calculate yet.
Okay. Firmly on the ground. Right. So this is the, so these are some applications or normal thing about the
Mm.
gravitation. Okay, that's good. Have you written it down? Please do let me know, Amithi.
Yeah, I'm done.
Done. Okay, that's great. Okay, now let's talk about the like basically the like the interaction between the two bodies in the universe. Okay, Amithi.
Mm.
So basically, suppose that you are sitting in Dubai, right?
Mm.
And this is like okay. So you and the whole universe are interacting with each other. It
Mm.
means that if you are exerting some force on the universe as well, okay,
Mm.
and same in the vice versa manner, universe is also exerting some force upon you, right?
Mm.
So if we basically conclude to a simple point, each and every body in the universe interacts with each other. It means that if suppose that I have pen, right? So right now in my hand there is a pen, writing pen, right? Stylus you can say. So this stylus is also exerting some force on me because my body is getting interacted with the pen. So that's why there is an equal and opposite reaction of the forces on me as well as the stylus. Clear?
Mm.
So in the
Mm.
simple words, according to Newton, every object in the universe attract every other object with a certain force. So we are going to study about the force, like the magnitude of the force, the effect, like factors affecting the force and all the things in the universal law of gravitation. But in the general word, according to Newton, if a person is there in the universe, so that person will attract each and every body in the
Mm.
universe itself. Clear? It means that you are attracting, you are exerting force on the whole universe, Amithi,
Mm.
according to Newton. And similarly, if you're exerting according to action and reaction forces, so the your you can say the universe is also exerting the same amount of force on you.
Mm.
Is that clear?
Yeah.
That's great. So let me write down some point about this. So this interaction is not like basically depends whether the thing is living or non-living. So if you are there in the universe, each every like non-living thing as well as living thing will be interacting with you. Okay.
Yeah.
Yeah, that's great. And this force is nothing but your gravitational force because two bodies are basically basically attracting each other. Okay. Okay. So now let's discuss like the what are the factors that will affect the force of attraction. In the simple words, the gravitational force. So in this, if the bodies, if there are like two bodies, so masses of the bodies are too small, then the force of attraction, or you can say gravitational force, would be very, very small. Okay. So that's why the gravitational force depends on the mass of the bodies. Clear, Amithi? That's great. Okay. If masses of the object are small, this is the short form of between. So you can write it in the notes, but in the exams, you have to write it completely. Okay, Amity? Between them is very small. Okay. So in basically, sometimes it is not like comparable, like it is not measurable as well. So these forces are that much small in magnitude. Okay, Amity? Next would be, so if any of the body, suppose that two bodies are interacting with each other, if one of the body is very large in the mass, so then the attraction will become very large. It means that the gravitational force will become very large. So let's take an example. Suppose, Amity, so our body as compared to Earth is almost negligible. The mass of our body is almost negligible because Earth has a mass of 6 into 10 to the power 24 kg. So that's a very, very big number. And our body is basically lies between 40, 50, 60 kg, right? So as compared to Earth, so that is almost negligible. Okay, so it means that whatever the force we are exerting on the Earth is almost negligible, but Earth exerts the same amount. Suppose that my body is there, so whatever the force I'm exerting on the Earth, so that will not affect the Earth, but the force that will Earth exert on my body, that will affect a little bit. That's why I'm basically standing on the Earth firmly, right?
Yeah.
So if one of the mass is very large, so that means the force will become very large. Okay, so
Mm.
in terms of like my body and the Earth body, so that force will basically somewhat like like 60 10 600 500 newton, somewhere around. Like it depends on the mass of the body, right? So 600 and 500 newton is not a very great mass, like very great force in magnitude. Okay, so if one of the objects is very big, the gravity force, sorry, force becomes very large. And its effect can be seen easily. Clear, everything?
Yeah.
Sure, that's great. Okay. So this is about the achievement. So if I'm talking about the gravitational force,
Mm.
gravity is always a force of attraction between the two bodies, Amity. Okay, if I'm talking about gravitational force, it means that two bodies are involved in that
Yeah.
scenario. Am I clear?
Yeah.
That's great. Is always between two objects. Right. So that is the basics, or you can say the fundamentals of the gravitational force. Is that clear to you, Amity? Any doubt so far to you? Please do let me know.
Mm.
Is there anything that is not clear to you so far?
No.
Is everything clear?
Yeah.
That's great. Okay, Amity. So now let me explain a little bit about the, just a second, about the universal law of gravitation. So basically in the coming class, I'll explain the universal law of gravitation along with the formula. But right now I'm telling you the concept about it. Suppose that, Amity. So just a moment. Right. So there are two bodies, right? So this is the universal law of gravitation that is given by the Newton itself. Okay. So just like this. So as you can see, these two bodies are there. Just a second. Let me place it right there. Right. So they are separated with a distance r from their center. Okay. So that is the radius. Not radius, or sorry, not radius, the distance r, or you can use d or x, whatever you want, right? It's up to you, any variable that you want to use. Suppose that the mass of this body is m1 and the mass of this body is m2, right?
Mm.
So Amiti, so the gravitational force between these two bodies basically depends on two things. First thing is basically I'm representing that force with the value of F, the force between the bodies, the gravitation. So it depends upon the, like as given by the Newton, it depends on the products of the masses. Clear?
Yeah.
Could you please give me